This lesson, we're going to learn how to use implicit differentiation to find the slope of a tangent. This differentiation will allow you to find the derivative of y with respect to x without having to solve the given equation for y. Example number 1, given the circle x squared plus y squared equals to 25. We want to find the slope of tangent to the circle at the point 3 and negative 4. The first way to do it is we're going to isolate for y, and we differentiate the equation explicitly. So step 1, rewrite the equation in terms of y squared. So y squared will become 25 minus x squared. And we have to get rid of the square by taking the square root, positive negative square root of 25 minus x squared. The next one, we have to get rid of the radicals. So 25 minus x squared to the exponent 1 over 2. Next, we are ready to differentiate. So we say dy over dx, which is a y prime, is going to be positive negative. Exponent bring it down, which is a half. And exponent take away 1, which is negative half, times by differentiation of the base, which is negative 2x. That simplified it. It will become negative positive x times by 25 minus x squared to the power negative half. And now let's substitute x equals to 3 to find the slope of a tangent. Slope of a tangent is going to be negative positive 3 times by 25 minus 3 squared, which is going to be 25 minus 9, which is going to be 16, to the power negative half, which is negative positive 3 times by 1 over square root of 16, which is 4. So now you have two different slope, which is 3 over 4 or negative 3 over 4. Now let's take a look at the graph. Because 3 and negative 4 is at this point on the circle, and slope of tangent is positive, so we know the slope of tangent cannot be negative. So we say, therefore, the slope of a tangent, which is going to be positive 3 over 4. Now, let's try a different method, implicit differentiation. So implicit differentiation means we do not need to isolate for y. So first of all, let's write down the equation x squared plus y squared equals to 25. And that's differentiate each term. Differentiation x squared, which is 2x. But right now you're differentiating the x term with respect to x. Plus y squared. Differentiation y squared is 2y. But now you are differentiated y term with respect to x. Equals to 25 is a constant, so differentiation will be 0. Now, let's look at what does it mean by dy over dx and dx over dx. dy means changing in the y values. dx means changing the x values. So changing the y values over changing the x value really means right over wrong. That's why we say this is slope of the tangent line. This one here, changing x over changing x, those two are the same constant. So when you are dividing by the same constant, let's say for example 2 divided by 2 or 3 divided by 3, you're going to get a 1. So this equation really means 2x times by 1 plus 2y dy over dx equals 0. And you often do not see people write dx over dx. So when they differentiate it directly from the blue line, they will write 2x plus 2y dy over dx equals 0. Next, we're going to isolate for dy over dx. So first thing, I'm going to subtract 2x on both sides of the equation. And next, we're going to divide it by 2y on both sides of the equation. And we can simplify it. So I know my dy over dx, which is slope of a tangent line, is going to be negative x over y. Now, what we need to do is to substitute the point in. Substitute 3 and negative 4. We know slope, which is your dy over dx, which is going to be negative x over y, which is negative x is 3, y is negative 4, which is positive 3 over 4. Therefore, the slope of a tangent line to the circle at the point 3 and negative 4 is 3 over 4. For example number 2, we're going to use implicit differentiation to find the slope of a tangent at x equals negative 3. So the first thing is we're going to write down the equation x squared plus 4y squared equals to 25. Now let's differentiate each term with respect to x. So differentiate x squared becomes 2x, differentiating the x term with respect to x, plus 4y squared, the differentiation will become 8y, and differentiate the y term with respect to x. 25 is a constant, differentiation will be 0. Once again, we know dx over dx is 1, so we can simplify to this. Subtracting 2x on both sides of the equation. And you divide it by 8y on both sides of the equation. And simplify the fraction. You have slope of a tangent line is negative x over 4y. Now, in order to find the slope of a tangent, I need to know both x and y values. So since only the x value is given, so I'm going to find the y values. So at x equals negative 3, we know x squared plus 4y squared will be 25. So negative 3 whole thing squared will be 9. Subtract 9 on both sides. Divided by 4 on both sides. So y is going to be positive negative square root of 4. So y will be positive negative 2. This means there are two different tangent lines when x equals negative 3 on this ellipse. So we have to find the slope of each tangent line. So at x equals negative 3 and y equals to 2, your dy over dx, which is slope of a tangent, will be negative 3 over 8, which is positive 3 over 8. At x equals negative 3, y equals negative 2, your slope of a tangent will become negative 3 over negative 8, which is a negative 3 over 8. Finally, let's substitute into the slope formula to find the equation. M equals to y minus y1, x minus x1. Our first slope is 3 over 8, and the point is negative 3 and 2. So y minus 2, x plus 3. Let's do cross multiplication. And bring everything to one side. And that's our first equation of the tangent line. The next one will be a negative slope, and the point is going to be at negative 3 and negative 2. So it'll be y plus 2, and that'll be x plus 3. Once again, you do a cross multiplication. Bring everything to one side. And that's another equation of the tangent line. Therefore, there are two tangent lines. One is 3x minus 8y plus 25 equals 0. And the other one will be at 3x plus 8y plus 25 equals 0. Example number 3, you can see the first term is actually 2xy. That means there's a product rule. The first function u is 2x. The second function v is y. So our differentiation will be this. U prime, which is 2, and you are differentiating the x term, dx over dx, which is 1. We don't need to write it. Times by v plus 2x times by differentiation y, which is 1, but you're differentiating the y term with respect to x, minus y cubed, the differentiation 3y squared, you're differentiating the y term with respect to x, equals to differentiation 4 is a 0. So there's the product rule here, u prime v plus u v prime, and your u is 2x, your v is y. Next, we need to simplify it. Since we want to find dy over dx, so we're going to isolate for dy over dx. So all the terms with dy over dx, we're going to leave them on the left. And all the terms without the dy over dx, we're going to remove them. So it'll be negative 2y on the right-hand side now. And we're going to factor out dy over dx. And now I can find my dy over dx by dividing it. Therefore, my dy over dx will be negative 2y over 2x minus 3y squared. Example number 4, this is a chain rule. So let's try this. Differentiation of the first term, I'm going to underline the pink. Chain rule is bring down exponent, and exponent take away 1, don't change the base, and now you have to times by differentiation the base. Now, differentiation x will become a 1, and dx over dx, which we're going to write it, plus differentiation of the y will become 1, but right now you're differentiating y term with respect to x, equals to, now x squared is the green one, so differentiation x squared becomes 2x, and dx over dx, you don't need to write it, so I'm going to erase this. Now, let's do the blue one, y squared. So differentiate y squared is 2y. Now I have to do dy over dx. Once again, we need to simplify it. Expand the left-hand side. Isolate for dy over dx. That means all the terms with the dy over dx, I'm going to keep them on the left. So I have to take this term to the left. I'm going to underline this so you see it. Equals to 2x. Now, I have to bring this term back. So minus 2x. I have to bring this term back. So minus 2y. Next, simplified it. Those two add up to 0. Those two add up to 0. So we have 2x dy over dx equals negative 2y. And by dividing by 2x on both sides and reduce them, so my dy over dx is negative y over x. Now, let's try a little bit more complicated questions. So first thing you do is you want to get rid of the radicals. And we're going to differentiate each term. So the first term is actually product rule. So you have to do u prime v plus u v prime. So differentiation of u prime, which is 1, by your differentiated y term with respect to x, times by your v, plus u, which is y, v prime, half, x power negative half. Now you're supposed to write dx over dx, but once again, because that's a 1, you don't need to write it, so I'm going to erase it. Plus, now, the second term, this is also a product rule. Now, this becomes our u, that becomes our v. So, u prime, which is 1, and dx over dx, because this is the x term. Once again, because dx over dx is 1, so you don't need to write it. And times by y half, plus u, which is x, and v prime, which is differentiation of y to the power half. So you bring down the half, y to the power negative half. You differentiate the y term with respect to x. And constant becomes a 0. Now we're going to simplify it by putting all the dy over dx at the end of each term. And keep all the dy over dx on the left-hand side, and all the terms with the dy over dx, put them on the right-hand side of the equation. The next step we're going to do is we're going to get rid of all the negative exponents and get rid of the fraction. Change them back into the radical. Next, we're going to combine those two terms into one fraction and those two terms into one fraction. And when you're dividing it, that means you multiply the reciprocal. And that simplified it. Divide the 2 up. Now we can see on the numerator, they have a square root of y in common. This is square root of x in common, so I'm going to factor another square root of y. Square root of y times the square root of y will become y. When you factor out the square root of x, multiply them will become x. So our final answer will be this. Negative y square root of y plus 2 square root of x. X square root of x plus 2 square root of y. And that's our differentiation. Example number 6, I want to show you whenever you have a fraction, you do not want to differentiate directly. You want to manipulate the function before you differentiate. So how do I get rid of the fraction now? You multiplied it. And you have xy squared minus y cubed equals to x plus y. And now it will make it a lot easier to differentiate. So let's differentiate each term with respect to x. So the first term here is a product rule. So differentiation x is 1, dx over dx, you don't need to write it. X times by differentiation y squared, which is 2y, dy over dx. Minus differentiation y cubed is 3y squared, dy over dx. Equals to differentiation of x is 1, differentiation y is 1, dy over dx. Now let's simplify it. And once again, you want to keep all the dy over dx on the left-hand side. And factor out the dy over dx. And by dividing by this bracket, you get dy over dx. And that's your differentiation.